Welcome to homework set number 12 for ECE 476-676 Advanced Embedded. In this homework set, we look at using a Wi-Fi network with the Raspberry Pi Pico to transmit and receive data. What I want to do is I want to be able to transmit data from a BME 280 sensor, temperature, pressure, humidity, and light level with a light sensor. Now what I want eventually is, here's at the Pico side, I'll want to have a web page set up where I've got the current temperature, humidity, light. As I darken it, see the light level is dropping. So you can see the updates once a second. If I close the blinds, make it darker in the room. Darker in the room. Light level drop down to 281. Turn off the lights. And I can turn on and off the NeoPixels. So here the light is red. Okay, there's red. Bit of a delay. Green, blue, and off. Okay, so how do I do that? First, I need to calibrate a light sensor. So to do that, I'm just going to take the light sensor and measure the resistance. I've got a phone app right here to measure light level. Based upon the phone app, assuming that's accurate, at 447 lux, my light sensor read 3297 ohms. At 30 lux, read 16.5 kiloohms. Gives me two equations, two unknowns. Solving for A and B gives me A is 125,000, B is 0.5966. So there's my equation relating resistance and light level. Solving backwards, given the resistance, I can then calculate the light level. In terms of coding, I'll set up a Wi-Fi link and a table. It'll display the temperature, humidity, pressure, light. Here's the web page I used. It's a table code from W3 schools modified, so I've got my table, the parameters, the values, and units. These are dummy variables. They'll be replaced by the actual values when I call it. The main routine then waits for a ping. When it gets it, it reads the temperature, pressure, humidity, reads the voltage, calculates lux, updates the LCD display, like so. Room gets dark. Oh. Turn off the lights in the room. Okay. Turn off the lights again. Turn on the lights. And so it is recording that. And update the web page. So the web page looks like this. So there's what's going on. Turn the lights off. Turn the lights on. Okay. Problem 4 was now test. So during the light levels, compared to my cell phone, when the blinds are open, lights are on, blinds closed, lights off, shades closed. Looks like it's reading. The second part of the homework is a Wi-Fi receive. I want to send data from a web page to my Pi Pico and control the NeoPixel. So here what I'm using tags, or hyperlinks rather than tags. The reason being is when I have tags, it locks up until I hit submit. With a hyperlink, I can automatically refresh, so every second the contents are being updated. And I can change the colors. In the main routine, I then check to see what gets returned. If it's red, green, blue, or off, it'll then set the color of the NeoPixel, as well as update the readings. And what that looks like is this. So here's the parameters. If I click the red light, It's a little bit of a delay. Then the red light turns on. Green light. Green light turns on. Blue. Blue light turns on, off. And in Thani, you can watch what's happening. In Thani down here, you can see the different commands. Let's pull that off to the side. Try to pull it off to the side. And Windows is biting me. Quit biting me. I think I'll put it over here. So here's red. There's a red command, green command, blue command, off. You can see the message coming up. That is homework set number 12 for Advanced Embedded.